So, today we will review the chain rule and related rates. Also, today you have some recitation activities. If you go Canvas, then you will find that. And the chain rule is, we already discussed before, that if you have a function y equals to f of g of x, where this g is called the inner function and f is called the outer function. So if you want to take its derivative dy over dx, then first take derivatives of the outer function f and keep same the inner function times, then take derivative of the inner function. This is the chain rule. And we need to find derivative of this one. So I can change the color. So we have y equals to square root of 3 plus 8 e to the power 3x. So this one I can rewrite this way: y equals to 3 plus 8 e to the power 3x to the power 1 half. So now this part is our inner function. Okay. Now if we take derivative with respect to x, so dy over dx would be, first take derivatives of the outer function. So if you have x to the power 1 half, then if you take derivative, you know it is negative 1 half. So same, it would be 1 half 3 plus 8 e to the power 3x to the power 1 half minus 1. I used the power rule. Now we need to take derivative of the inner function, which is 3 plus 8 e to the power 3x. Okay, so this becomes 1 over 2 3 plus 8 e to the power 3x to the power negative 1 half times, if you take its derivative, it becomes 8 times 3 e to the power 3x. So the answer is, if you cancel this 2 and 8, it becomes 4. So 12 e to the power 3x over square root of 3 plus 8 e to the power 3x. So this is the answer. And you have a bunch of formula, chain rule variants, and your instructor already discussed those. And you also learn like derivatives of logarithm function. So if you take derivatives of the natural logarithm ddx of ln of x, then it is 1 over x. For natural logarithm, the base is e, okay, and it is read as ln x. Now how about this one? So we have ddx of, here base is x, sorry, base is a, right? So what we can do, we can change the base and we can rewrite this one e to the power x times log a e. This is times, and you can also rewrite this one as ln of x and this part becomes log of e to the power a. Okay, so d dx of ln of x, and since this is base e, so we can write this one as ln a, and ln of a is constant, so 1 over ln of a d dx of ln of x, and if you take derivative of ln of x, it is 1 over x, and finally you will get x ln of a. This is the result. Okay, it comes this way. Similarly, you can derive this one. There are few more formulas for inverse trigonometric functions. You need to remember some formula. This one, also this one is very important. Now, in this example, we need to find equation of the tangent line to the curve given by this one, and point is 2, 0. Okay, so we know equation of tangent line, y minus y1 m times x minus x1. We have already given x1 y1 as 2, 0. What we need? We need m, the slope. So how we can find the slope? If we take derivative of the main function, then dy over dx would be the slope. So take derivative and it becomes dy over dx equals to 1 over x square minus twice x plus 1, and take derivative of the inner function, it would be twice x minus 2. So when x is 2, then dy over dx is, these 2 comes from here, these 2. Okay, so dy over dx would be 2 times 2 minus 2, and 2 square minus 2 times 2 plus 1, which is 2 over 1, 2. So the slope is 2. So m is 2. So what would be equation? So slope is 2. So equation would be y minus y1, y1 is 0, then m is 2, x minus x1 is 2, and this is y equals to twice x minus 4. So this is equation of the tangent line. Now we will discuss related rates. Now, to get idea of related rates, I can show you some picture. Suppose we have this conical tank this conical tank. Okay, then when water is drained out of the conical tank, the volume of the volume V, the radius R, and height of the water level are all function of T. So if you pour water and also drained out water, then the height, the volume of the water, and radius of the water level would be function of T. Okay, so we know volume is pi r square over 3. Okay, volume of a cone, its formula is 1 over 3 pi r square h. So V is 1 over 3 pi r square h, and the radius changes with respect to T. The height of the water level also changes with respect to T. Okay, the radius R, the height h. So if we take derivative dv over dt, then it would be T of r square h. So pi over 3 use the product rule, so dr 2r, then dr over dt times h plus r square times dh over dt. So this would be the formula. Okay, and in our problem maybe we will have some, suppose dr over dt is given and dh over dt is given, and we need to find dv over dt. Okay, let's discuss few example. In this example we have given that the variable x and y are both differentiable functions of t and are related by the equation y equals to x square plus 3. We need to find dy over dt when x equals to 1, given that dx over dt is 2 when x equals to 1. So we have equation which is y equals to x square plus 3. We have given rate dx over dt when x equals to 1. We need to find dy over dt when x equals to 1. Now if you take derivative of the equation, if you take derivative of the equation star, then it becomes dy over dt equals to twice x times dx over dt. Okay, we need to find dy over dt when x equals to 1. So plug x equals to 1 and dx over dt, dx over dt is 2. Dx over dt is 2, it's given, and dx over dt is 2. So it is 4, and it doesn't have any unit, so you can write just 4. So this is the answer. dy over dt is 4. Let's discuss one more example from ripples in a pond. So a pebble is dropped into a pond. So this is a pond, causing ripples in the form of a concentric circles as shown in the figure. The radius of the outer ripples is increasing at a constant rate of 1 foot per second. When radius is 4 feet, at what rate is the total area of the disturbed water changing? So here we know equation. So those are circle, right? Circular path. So equation we know pi r square, equation of area of a circle, pi r square, and given rate find. So given rate is given like the radius r of the outer ripple is increasing at a constant rate 1 foot per second. So given rate dr over dt is 1 foot per second, and we need to find when radius is 4 feet, at what rate the total area is changing. So we need to find rate of change of the area when r is 4 feet. Okay. So how we can find? Take derivative of this equation with respect to with respect to t. So dA over dt would be dt of pi r square, and pi is a constant, so it becomes 2r times dr over dt. Now we have given that r is 4 feet and dr over dt is 1 feet per second. So plug those value here. So pi times 2 times 4 times dr over dt is 1, and it becomes 8 pi and its area, so feet square per second. Okay. So this is the answer. d over dt is 8 pi feet square per second. Now discuss this problem. So an inflating balloon, air is pumped into a spherical balloon in this figure at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 2 feet. Okay, so this is spherical balloon, and we know the volume of a sphere is 4 over 3 pi r cube. Okay, so we know equation V equals to 4 over 3 pi r cube, and given rate, and we need to find the given rate is the spherical balloon at a rate 4.5 cubic feet per minute. So dV over dt is 4.5 cubic feet per minute. Okay. And we need to find the rate of change of the radius dr over dt when radius is 2 feet. Okay. So what we can do, take derivative of this equation with respect to t. So dv over dt would be 4 over 3 pi. If you take derivative of r cube, it becomes 3r square dr over dt. Okay. Now plug all of those values. So dv over dt is given 4.5, and this 3, that 3 cancel. 4 pi, r is 2, so 2 square times dr over dt. So dr over dt would be 4.5 over 16 pi, which is approximately 0.09 foot per minute. So this is the answer. The rate of change of the radius would be 0.09 feet per minute. Now solve some problem which your instructor discussed in class. So your professor discussed this one in class. So here we need always 3 information, like first equation, then given rate, and we need to find. So the radius of a sphere is increasing at a rate 4 millimeter per second. How fast the volume increasing when the diameter is 60 millimeter? So we need to find volume, rate of change of the volume of the sphere, and we know volume of a sphere is V equals to 4 over 3 pi r cube. As we discussed in last problem, that was balloon. So this is equation, and the given rate is the radius dr over dt equals to 4 millimeter per second, and we need to find dv over dt, like how fast the volume increasing when diameter is 60 millimeter. So diameter means twice r is 60 millimeter. Okay, so what is r? R is 30. So when r is 30 millimeter. Okay, so as before, take derivative of the equation. So with respect to t, so dv by dt would be dt of 4 over 3 pi r cube, and this equals to 4 pi over 3 times 3r square times dr over dt. Now plug those information. So 4 pi, we can cancel this 3. So 4 pi times, what is r? R is 30. So 30 is square, and dr over dt is 4. And if you simplify, it becomes how much? 1440 pi millimeter cube per second. So this is the answer. So dv over dt is this one. Now discuss next problem. So two cars start moving from the same point. Okay. One travels south at 48 miles per hour and other travels west at 20 miles per hour. At what rate is the distance between the car increasing 3 hours later? So first draw the figure. So in paper we normally write this one east, this side is west, this is north, and this is south. Okay. So both cars start from this point, and one car moves south. So south, this direction. One car moves this direction, south, and another car moves west, so this direction, and so and we need to find the rate of change of the distance. So this is, suppose O, and this is X, this is Y, this is X, this is Y, and this side is Z. Okay. So if it travels 48 miles per hour, then after 3 hours it goes, so Y would be 48 times 3, which is 48 times 3, 4, 144 this mile, and x would be 20 miles, which is 60 mile, and now the equation is equation this is a right angle triangle, so we can apply the Pythagorean theorem, x square plus y square, and we have given rate, and we need to find, so given rate south, so dy over dt is 48 mile per hour, and dx over dt is 20 mile per hour. We need to find dz over dt when, after how many hours? 3 hours. So t equals to 3. So take derivative of the equation, this one, so it would be 2z dz over dt equals to twice x dx over dt plus twice y dy over dt. So we need to find dz over dt would be 1 over z x dx over dt plus y dy over dt. Okay. We also need to find g. So from this graph we can find g. So x square plus y square, which is 144 square plus 60 square, and after calculation we will get 156. Okay, 156 mile. So now plug all of those information here. So 1 over z is 156, x is 60, dx over dt is 20, y is 144, and dy over dt is 48, and after simplifying we will get 52 mile per hour. So dg over dt is 52 miles per hour. Now we can discuss the next problem. The top of a ladder slides down vertical wall at a rate of 0.375 meter per second. At the moment when the bottom of the ladder is 6 meter from the wall, it slides away from the wall at a rate of 0.5 meter per second. How long is the ladder? So we can draw a graph like this. So suppose we have a vertical wall and this is the ground. And there is a ladder. Suppose this one is the ladder. So we have this wall and this distance, the bottom of the ladder is 6 meter from the wall. So this distance is 6 meter. This distance is 6 meter. If this is x, this is y, and this is z, then our equation would be z square equals to x square plus y square. And what is given? So given rate vertical wall at a rate of 0.375 meter per second. So this distance is decreasing, y is decreasing at a rate of 0.375 meter per second. Since it is decreasing, we will put a negative sign and we need to find z. Okay. We also have more information. It slides away from the wall at a rate of 0.5 meter per second. So dx over dt is 0.5 meter per second. So using this information, we need to find z. And here z is a constant because the size of the ladder cannot change. Okay. So if you take derivative of this equation, you will get 2z dz over dt equals to twice x dx over dt plus twice y dy over dt. Since z is constant, so dz over dt would be 0. So 2z times 0 and twice x dx over dt plus twice y dy over dt, and you can rewrite this one as x dx over dt plus y dy over dt is 0. So we also have x. X is given 6 meter. So plug those information dy over dt, dx over dt and x, and you will get y. So x is 6 times dx over dt is 0.5 plus y, and dy over dt is negative 0.375, and if you simplify you will get y equals to 8. So we got x equals to 6 and y equals to 8. Now if you plug those two values x and y in equation 1, then you will get z. So x equals to 6 and y equals to 8 in equation star. We have z square equals to 6 square plus 8 square. So z square equals to 100 and z would be square root of 100, which is 10. There is a plus minus sign here, but it would be always positive because the length cannot be negative. The length of the ladder cannot be negative, so it would be always positive. So this meter, this is the answer. So that's it for today's lecture, and please complete your recitation assignment and see you next time. Bye.